Every engineering team eventually hits a wall where crucial architectural decisions slip into a dark void of Slack and Discord threads. Standard chat search usually returns a fragmented list of results. Developers end up wasting hours digging through old channels, or they simply ask the exact same questions all over again. This creates a significant barrier for new hires. The institutional knowledge they need to get up to speed remains locked away in history they weren't present to see. Beaver Atlas is an open-source platform designed to rescue that siloed data from tools like Slack, Teams, and Discord. It is built to be telemetry-free and self-hosted. Your proprietary discussions stay within your own infrastructure, allowing for entirely air-gapped deployments. Securing your team's knowledge requires taking direct ownership of the data extraction process, rather than relying on a third-party chat app's search function. The Atlas ingestion pipeline pulls live conversation history, extracts core facts, and deduplicates the noise. These facts are mapped into structured topic pages. Each entry includes a direct citation that links back to the original source message that produced the fact. Manual documentation usually goes stale the moment a new decision is made in a chat thread. This system updates its records automatically as new messages arrive. By distilling raw chat logs into an organized team brain, your internal documentation remains as current as your team's latest conversation. Generating an auto-updating wiki requires more than just a simple script. It demands a complex backend infrastructure. The platform runs as a heavy Docker stack. You are essentially managing 4 distinct and demanding databases simultaneously. Weaviate is used to store vector embeddings, which enable semantic similarity searches across your organizational knowledge. Neo4j acts as the graph database, responsible for mapping the relationships between people, projects, and specific decisions. MongoDB and Redis are required to handle the application state, the wiki cache, and user sessions. This architecture places a heavy baseline drain on your local CPU and RAM just to keep these services spinning in the background. Because of these requirements, running Atlas on older hardware or in resource-constrained environments is essentially impossible. Private, local AI reasoning requires a significant infrastructure investment, often demanding dedicated DevOps attention to maintain. The reason for this complexity is to address the accuracy issues found in standard AI chatbots. A smart router directs every question to either a semantic vector search or a graph traversal, depending on what the user is asking. Graph-aware reasoning allows the system to answer relational questions, like who worked on Project X, which often cause standard vector-based AI to fail. Retrieval operates against the distilled wiki pages, rather than the noisy chat history. This structure provides traceable citations back to the original messages for the claims the AI makes. Enduring the complex database setup provides one primary utility for software developers. The backend exposes a Model Context Protocol, or MCP, server. This creates a bridge for external AI agents to access your internal knowledge base. AI-powered IDEs like Cursor or Claude Code can connect to this MCP endpoint, allowing them to pull context directly from your backend. You can query your company's entire legacy chat history from within your terminal. You get the context you need without ever having to switch apps or lose your train of thought. The MCP server provides 16 specialized tools that allow your coding agent to perform its own graph traversal and vector retrieval natively. Because these tools have such deep access to your internal data, you must implement strict per-agent authentication to manage who can query your legacy decisions. This immediate, context-rich access to historical engineering decisions is the primary incentive for taking on the resource-heavy infrastructure burden. Before rolling this out to a team, you need to be aware of the project's current maturity. Beaver Atlas is currently in an early access version 0.1.0 release state. The documentation explicitly states that all current REST APIs are unstable. Any custom integrations or internal tools built on the current API will likely break when version 0.2.0 is released. Adopting the platform now is an investment in an architecture rather than a stable, set-it-and-forget-it solution for today. The ideal user for this tool is a platform engineering team with the server resources required to host a 4-database stack. It is also a fit for teams already using AI-driven IDEs, who have strict requirements for data privacy and zero telemetry. Avoid this tool if you're a lean startup without DevOps bandwidth to manage local infrastructure. A managed SaaS is a better fit. Similarly, it isn't suitable for users on low-power hardware or teams needing absolute API stability right now. The final decision depends on whether the enhanced developer context is worth the undeniable burden of maintaining a heavy local infrastructure. Subscribe for more architectural breakdowns of early-stage open-source tools. Maintaining true private control over company data always requires a willingness to master the underlying infrastructure.